Great to catch up with the astrophysicist and Professor Jonty Horner from the University of South Queensland. Professor Jonty, here we are. We've collided a satellite into an asteroid. Why?
To prove that we can. It's a really interesting thing. It's all about demonstrating that if something was coming on a collision course with the Earth, we could take matters into our own hands, turn that hit into a miss, and save the whole of humanity. So this is a really fun story. It's the idea that we can learn to play planetary billiards and in the process take asteroids that would hit the Earth and make them miss. I mean, how cool is that?
It's quite fascinating. In fact, one of our other staff that you spoke with previously, Clayton, he's a snooker enthusiast. We were talking about whether we had backspin on the satellite or not. Just how hard would it have been to actually make this collision in a way that works?
It's a real challenge, and this is demonstrating that we can do it. So the first thing I should really reassure people is that the asteroid that has been targeted is no threat to the Earth. It's not actually coming anywhere near us, which means this deflection will not accidentally point it in our direction. So we're not going to accidentally kill the Earth by practicing. This is well and truly safe. They've picked a really special asteroid here. It's called Dimorphos. It's about 180 meters across, and it is the moon of a bigger asteroid called Didymos, which is about 680 meters across. And by targeting this binary asteroid, we can see the rate at which this little asteroid is going around the big asteroid change. So it gives us a very accurate measure of just how effectively we've deflected it. And the expectation at the minute is that its speed around the bigger asteroid will change by 0.2 millimeters per second. A tiny little nudge. And that makes sense. What we've done essentially is to crash a fly into the windscreen of a big road train going through the desert. That's the kind of equivalence you're talking about here. And in fact, the difference in the matters is even bigger than that. So achieving a tiny little deflection of 0.2 millimeters per second doesn't sound much, but that adds up over time. So if you change the speed by 0.2 millimeters a second, after 10 seconds, the position is different by 2 millimeters. After 100 seconds, it's different by 2 centimeters. 1,000 seconds, 20 centimeters, and so on. And so because that difference will gradually mount up over time, if you deflect it early enough, you really do turn a hit into a miss. You can deflect it by more than the diameter of the Earth just by having that lead time and doing essentially what they've done today.
Yeah, Professor, that's a really great point you've made, because at first I heard the commentary immediately from Mission Control saying, Earth 1, asteroid nil, and I thought, gee, if it was just like a bug on a windscreen of a road train, surely it hasn't made that big an impact. But that's what we're talking about, is we hit something early enough once it's detected, it's going to spin off and not, maybe, what would it do? Would it skim our atmosphere and burn up, or actually just not go anywhere near Earth altogether?
It would hopefully miss by a comfortable margin. I mean, the closer the miss, the more nervous we'll get, because there are a lot of other things going on than just gravity that can nudge and pull these things around. So you really want to be as safe as possible and miss by as large a distance as possible. And, that just depends on getting enough prior warning. And so what goes hand in hand with this kind of mission is the ongoing endeavour that people worldwide are doing to detect the threatening objects well in advance of any potential collision with the Earth. And we've actually had a few successes in recent years where things have been found prior to hitting the Earth and the collision has been predicted, the location has been predicted and the time, and then it's happened. And they've all been really tiny asteroids that pose no threat, but they demonstrate that we can predict these collisions. Now, a bigger threat is a bigger object, and hopefully we discover that further away. But this is part of why astronomers are a little bit twitchy about these satellite constellations that have been launched by people like Elon Musk, because the more things we have in orbit around the Earth, the harder it is to spot the things coming in that have the potential to hit us. And so there's a little bit of a dance going on at the minute trying to understand the balance between having satellites around the Earth to spread satellite communications with the challenge of finding things that could potentially hit us and put us at risk, and finding the happy medium there. And that is an ongoing discussion that will run and run and run, I'm afraid.
Yeah, that's fascinating. You use the analogy of a bug on the windscreen. It's a bit like saying we need to clean the windscreen. I thought we talked on our breakfast show recently how the American government has been saying, look, we need to clean the windscreen, so to speak, so we've got better visibility.
Pretty much. And it's a real challenge because the use of space around the Earth is not currently regulated in a global sense. Everything goes back to the Space Treaty of 1967, when the only players in the space game were countries who were launching a couple of things per year. So when you're now seeing thousands of things per year being launched, it's a totally different game, and it's a bit like the Wild West. The use of space has really far surpassed our ability to legislate, And that means that there are very challenging conversations to have. And I totally understand the desire to have faster internet in regional regions. I think that's a fabulous goal. But it's all about managing it in a way that we get the best of both worlds, that we don't spoil the cultural heritage of the night sky, that we don't spoil our ability to study the cosmos and look beyond. That, like I say, we find that happy balance where we can essentially have our cake and survive to eat it.
Have we had a disintegration of sort of, I guess, everyone being all in this together in the space sense when you look at China and Russia, who are bigger and bigger players in space, and the deterioration of geopolitical, there's tensions now between all those in the West?
That's always an interesting thing to follow. And I know China and Russia are doing some great things in space, particularly China. China have got their own space station going. They're talking about doing their own missions to the outer solar system. They're doing fantastic things. And it's an interesting conflict because on the political sense, yeah, you have China doing their own thing, the US doing their own thing and not really talking to each other, and other countries a bit piggy in the middle. But for the researchers involved, they genuinely don't care where you work. You collaborate with people who are your friends, and they get a new job in a different country and you keep working with them. But it brings challenges when a colleague moves to China, and we've actually seen this recently with friends of ours who work for NASA looking for planets around other stars who had one of their star colleagues take a job in China. And suddenly they're not really allowed to talk to one another. And so there are challenges there, and it's interesting to see how that washes out in the future. But for something like this, it isn't like the US is going to send a mission up to deflect an asteroid to save us and the Chinese are going to send one up to stop them. Everybody would work together with it. And similarly, if the Chinese sent up a mission to deflect an asteroid that was threatening the Earth, people would work together.
Yeah, thankfully, mutually assured destruction does tend to bring people together. Just lastly, while we're talking asteroids, science fiction, planetary defense systems sort of gets the science fiction brain ticking. But these asteroids, is there ever a chance that we might sort of mine them, that we might tether them or somehow bring them closer to Earth and extract maybe rare minerals from them?
Absolutely, and I think that actually plays a role also in the talk of deflecting them. Because if you think about what you do when you mine an asteroid, which we can't do yet, but we're getting there, we have landed on asteroids and brought pieces back already, so that's very near future technology now. If you mine an asteroid, you dig bits of it up and you throw them back to Earth for us to collect. The asteroid will recoil in just the same way as if you went to a shooting range and you shoot the gun, the rifle recoils in your hands. You feel the same kind of thing. So the technology we need to extract resources from asteroids, which I think would be a great achievement, particularly because the resources people would look to extract are very environmentally damaging to extract here on Earth. So if you mine them on asteroids and not mine them on Earth, you improve our environment naturally by not digging holes and polluting things. But also, by having that technology to extract things from asteroids, throw it back to Earth, you're essentially building a rocket on the surface of an asteroid that will push that asteroid around. And if you can push an asteroid around, you can save mankind because you can turn the threat into a near miss. And instead of having the thing crash into the Earth, we can watch it sail harmlessly by.
Mind-boggling stuff. Astrophysicist and professor from Uni of South Queensland, John T. Horner, thanks so much for giving us a lot more detail than we could have on the air about this DART mission today here. Thanks again for joining us.
It's an absolute pleasure. Thank you so much for having me.